Thank you very much for organizing this event and inviting us to present SUNRISE-6G, the Pan-European 6G Federated Infrastructure Flagship Project. I'm Christos Verikoukis from ESI ATHENA. The scope of SUNRISE-6G is to propose a scalable, open, standards-compliant approach to experimentation and vertical application deployment in a pan-European federation of 6G infrastructures that provide access to a comprehensive library of 6G enablers. We have with us key participants from all Stream C Phase 1 project. Almost all the testbeds are on board of SUNRISE-6G. We have testbeds from other SNS Phase 1 projects. We have testbeds from national 6G initiatives and the Slices RI partners of the Slices RI project. About SUNRISE, we addressed, as Chiara said, the Stream C0101 call. Our budget is 13.1 million euros. We will run for 36 months, and we have on board 28 partners, a well-balanced consortium between industry and academia. We have 13 partners from academia, from Tier 1 universities and research center and well-established testbeds. We have 8 big companies from Europe. Some of them offers their testbed, and 7 high-tech SMEs. ESI ATHENA will lead this project, and we have 2 technical managers, Kostas from Equadrat and Adriana from Equadrat, while Pavlos is our project officer. What we do in SUNRISE-6G? Inspired by the vision of network of networks, we propose a sustainable approach to the federation of 6G infrastructures, and we offer streamlined experimentation by third-party experiments. We have 6 well-defined technical objectives. One is to deliver this pan-European experimentation facility. The second is to implement an open federation framework supporting vertical use case deployment, to ensure the inviolability of the facility, offering streamlined testbed onboarding workflows, to validate the federated facility via advanced use cases, showcasing, etc. Offer a 6G library with breakthrough solutions that will be tested in the federated facility, and facilitate intent-driven life cycle management of experimentation. Finally, we have an objective for the dissemination, standardization. This is very important, and exploitation. Regarding the architecture, we decided to keep federated. The federation of its platform is decentralized, and we have a centralized experimentation plane that will be hosted in our facilities. The communication between the experimentation plane and the federation plane is done using these Camara service APIs or the CSMA operator platform group APIs, and we expose these testbeds in a testing as a service manner to a sustainable facility, and we will offer this pan-European experimentation facility during the SNS program. We have 4 main innovation areas: federation framework, 6G library for experimenters, AI plane, and experimentation plane. We'll go through this during the next slides. The federation framework, we designed 3GPP compliant federation framework, where the idea is to offer run exposure as a new network as a service API. We will implement selected Camara and GSMA OPG service APIs, offering cross-testbed service deployment and enablement. We will design transformation function in order to translate vertical-oriented Camara APIs to testbed-oriented internal APIs. We will offer open source SDK of transformation function and edge cloud APIs. We'll design a NOR and a RAP for run exposure, that offers the northbound APIs in a similar way as the network exposure function, and we will define simplified run exposure service APIs that translate the error APIs and BI towards the service developers. Regarding the library for experiments, we offer a set of 6G solutions like new service APIs for run exposure, crossover vertical development, deployment, and digital twinning. We will offer near-field reconfigurable intelligent surfaces with integrated communication and sensing. We will offer also joint communication and sensing in disaggregated networks. We will have non-terrestrial 6G network access and solutions. And we also offer native AI integration of testbeds towards intent-driven lifecycle management of the experimentation processes. Another innovation is the AI plane. We received a lot of feedback and very good comments about this. We will design pipeline orchestration and model serving via distributed collaborative MLOps. We'll offer edge intelligent agents. We'll design explainable foundation models. We'll have testbed supernodes with advanced capabilities that can support AI as a service workflows. This AI as a service offered towards other federated testbeds or third parties. Let's say we have other testbeds or private networks that can be plugged to our facility. And in order to give some more information about this this innovation, we can see here that we have this workflow and the super nodes, and we design and integrated end-to-end AI toolkit, cross-testbed MLOps pipelines, and that can perform prediction, classification, and anomaly detection tasks, and allow the testbeds also to share computational and computational resources, this AI as a service paradigm. Finally, for the intent-driven experimentation, we extend the 5G Media Hub, a 5GPP project led by the Quadrat portal in order to adjust to this SUNRISE-6G. We will design experiment scheduler in the lifecycle management. We will also offer experiment blueprints and tools coming from the different testbeds of the project. We also design reconciliation of intent using natural language models. In this case, we have intent-driven experimentation, and we have integration with the intelligent agents from the end-to-end AI framework. Regarding the validation, we have three very well-defined use cases. The first one is about federated metaverse. In this case, we have a platform that enable cross-domain metaverse-like services. We will test the facility in a mining infrastructure, having multiple autonomous vehicles, robots, in a collaborative approach. And also we have federated MTM, where we have mobility scenarios with static and mobile compute nodes in a federated NTN system. And we will also test multi-connectivity and inter-PLMN handover scenarios. Going one step further, we'll have 12 functional tests from all 6G library components remotely accessible from the experimenters. This 6G library is also open to external researchers to offer their 6G solutions. We'll have showcase federation with non-EU testbed, a testbed from US, considering different risks and compliant with this with the Open RAN. We will also have federation with at least 2 EU compared testbeds in cooperation. We will also offer the platform to external testbeds. We will demonstrate the federation of third-party testbeds outside of the SUNRISE-6G consortium, and we will showcase this in some events. And we offer the facility to all testbeds comes from stream A and stream B projects of the SNS program. Finally, I would like to say that each use case and each functional test will offer open data sets to the scientific society. We know that we lack of data from 6G for training AI algorithms. Another important topic I will close is standardization. We have a very good and focused standardization plan to contribute to ITUT, ETSI, 3GPP. This is very clear in our proposal, in our roadmap. We also have planned to contribute to some open source initiatives. And to conclude, our first achievement is standardization. In the recent meeting that took place 2 weeks ago, I think in Athens, our colleagues from Lenovo managed to present and get accepted 3 contributions. That's very good for us. You can find all this information to our website and our social media.
Thank you very much, Christos.